Hi, good afternoon. This is Mr. Cassidy, and today I'm going to be going over a quick overview of Chapter 4, Lesson 4, Linear Functions. So let's begin. Uh, what we've covered so far is linear functions, and functions are equations. They're basically a rule that is going to create a relationship between x and y. And we've learned so far how to enter those in a table. And so what we typically do is we're going to enter a few numbers for x. Let's go ahead and do -2, -1, 0, and 1. And what we do is we substitute those numbers in for x in the rule. And so here I would fill in 2 times -2 minus 4. And I would solve that either on a calculator or, do each step. Remember, PEMDAS, do your multiplication first. In this case, I would get a -8 for y. Now, what's new in lesson 4, so this is already a function table, we would just continue filling in 2 times -1 minus 4, which gives us a -6, and so on. I'll go and complete that briefly. And here we would have a function table already filled in. Now our goal in this lesson is to actually turn that into a graph. And so this is again building on our chapter 3 knowledge. We change these x's and y's into a coordinate pair. I'm going to pull the x number first. -2 was the input on that function, and -8 was the output. That's going to be the height of that value. And then I'm going to graph that, starting with my pen or pencil at the origin. I've first moved 2 to the left, because I always go left to right first, and then 8 down. In this case, this goes off the graph, but I'm going to have to estimate it right about here. All right, next one. How about I have -1, comma, -6? Okay, well, -1, comma, -6. Start with your pen at the origin, go to the left one, and down 6, and we would be here. I'm going to go ahead and fill in the rest of those where they belong. And what you should see happen is, because these are linear functions, linear means they form a straight line. And as carefully as I could, on paper I would use a ruler, but can't quite do that here. I would fill in a line. So linear graphs are going to form straight lines. And our goal is connecting functions with what we've done in chapter 3, being able to graph a straight line from the rule 2 times the number minus 4. Now it's your turn. So here's the function 2 minus x. Let's go ahead and start with, I don't know, -2, -1, 0, and 1. First, what would you fill in this box here? We should have filled in 2 minus, and then in parentheses, I would write -2. Awesome. Now remember, use the rule of 2 sticks here. Minus a negative becomes 2 plus 2. So what do we get as our y value, our output here? You should have gotten 4. Remember, 2 minus -2. What we're going to do is change the sign to addition. All right, go ahead and carry on. Go ahead and fill in here 2 minus -1. What's your y value? You should have gotten 3. And I'm going to go ahead and skip filling this in. You do it on your own. And what's your y value when x is 0? Okay, you should have gotten 2. And last, what's your y value when x is 1? You should have gotten 1. All right. Now, starting from our top row, we create coordinate pairs. For instance, the first coordinate pair I make is -2, comma 4. And to graph that, I'm going to go left 2 and up 4. What's the next coordinate pair for this graph? You should have said -1, comma 3. And to graph that, we go to -1 on the x-axis and up 3 for y. How about the next one? What's the coordinate pair here? Should have come up with 0, comma 2. And as a bonus, remember, what do we call that spot where it crosses the y-axis? That's the y-intercept. Okay, finally, our final dot would be at 1 comma 1, and I'll just do that one for you. Okay, we connect these dots with the straight line. And what do we call a straight line on a graph? Call it linear. Awesome. Now, to preview, this is really the main idea of the lesson is being able to graph that, but also to be able to do it in a real life situation. So here's an example. What if we have everybody going to a store and everybody who walks in gets a $5 off coupon? They get a $5 coupon every time. How would we write that as an equation? They get $5 per person. Well, we might write that as an equation, y equals 5x. And to write that as a function, all we do is we're going to change that y to f of x equals 5x. Don't worry too much about this. If you're confused, you're going to cover that a lot more next year. But the main idea is we're writing the rule $5 per person. Well, we could write a function as that, and then we could write a table. Now, y would be the total money saved by people, and x is going to be the number of people who come into that store. So what does it look like on a table? Well, it's going to look something like this. We'd plug in the 5, the 10, and so on. And then if we had to put it on a graph, it would look like this. So here's, I've got number of customers. With 5 customers, they would be at $25 off. At 10 customers, they would have given out $50 in coupons, total value of coupons given out. Well, why am I covering this? Notice that this graph is just dots. We have a word for that, and it's our new vocab, continuous or discrete. This graph is discrete. The graph we did earlier in the lesson, if I were to go back and show you the slide, was continuous. Let's see if you can figure out the difference. So, the idea is discrete graphs can only be whole amounts. So, for instance, if you've got a word problem with tickets purchased, right, you can't buy half a ticket, you can only buy whole amounts. So that's discrete. Number of people is a discrete amount. You aren't going to have half a person going to a movie, you're going to have a whole person. Number of tires on a vehicle, that would be a discrete amount. There can only be whole tires, you can't have half a tire. And number of sugar packets, that would be a whole amount. So that example we just went over, number of customers and the amount of coupons, is discrete. And all we're going to do with the discrete graph is we graph the dots. And here's my way to help you remember it. Discrete and dots both start with the letter D. Discrete means just the dots. Now, the opposite of discrete is continuous. Here's an example of a continuous graph and some examples of continuous things in word problems. Time, temperature, measuring length, amount of sugar in coffee. Notice all of these can be half amounts. So, like if I were to time how fast somebody can run the mile, that time would be in seconds and milliseconds, and all of those little amounts could be graphed. Temperature is the same thing, since 38.4 degrees is a little bit less than 38.5 degrees. That involves decimals or fractions. So basically, if it can be fractional or decimal in the description, then it's going to be a continuous. And how we're going to graph that is with a fully connected line. And so the question we're trying to answer is the situation discrete or continuous? Should we graph with dots or lines? And that's where we're going to head into in this lesson. So I thank your minds and your hearts, and I wish you a good math afternoon. Bye.